Now, basically, uh, how exactly what I meant to say, I'll just, if, basically first address is given. Why, what is the significance of this first address or called as network address? Got the idea? Whenever, suppose there are M connections in the network, you got the idea? M connections are there in the network, and then what I'm saying, rather I'm saying that yeah, our internet is made up of M networks. So M networks can be 100 networks, M can be 200, 2000, 2 lakhs, 2 lakh 50,000, anything. M networks I'm saying, and there is a router with M interfaces only. So for simplicity, if I'm taking, assuming that I'm having in the internet 3 networks only are there. You got the 3 networks are there. So and the net router is having 3 interfaces. So what whenever a packet arrives at a router, it will check what is the destination address. You got the idea? What is the destination address in the packet? That the destination address where the packet is supposed to go, right? Where the packet is supposed to go. So it will see the destination address, and based on the destination address, it will have what I want table. You got the idea? Where it will see which interface of the router that particular packet must be forwarded to. So this is how what I meant to say it will be done. It has been shown in the what I meant to say this thing. So we'll have that table called as forwarding table. Now, whenever packet arrives, so router will consult its forwarding table and then decide which particular what I meant to say in interface of the router should this packet be forwarded to, so that it reaches its destination. So that it reaches its destination. Let us see the diagram and try to understand this. Now, assuming that this is the routing process, so destination address has been given to be B2, C2, D2, E2. You got the idea. So now B2, C2, D2, E2, this router will find a network address, and this is the forwarding table present with the router. It says that this is not the address. It is B1, C1, D1, E1, which is not the given network address to which it is supposed to go. But B2, C2, D2, E2 is there. It has to go through interface number 2. So router, what it will be doing the moment this packet arrives, it knows that this particular packet which has come inside the router, you got the idea, is supposed to go to network 2. I mean to say interface 2, which is connecting network 2. And this is how the packet will be forwarded. This is how packet will be forwarded. So students, have you understood how exactly packet is forwarded whenever any network address comes to the router?
Yes, sir.
Hello.
Yes, sir.
Okay, fine. So this you have seen the moment any this is the router and from any network suppose this was the network, and from this this particular address had come here. Now router will check its forwarding table, that destination address it will what I meant to say destination network address it will find. So which is this. So it has come from this. We are not bothered. Now, to which a particular what I meant to say packet will be sent through which particular interface. Interface means connectivity. So it knows that from this forwarding table, it knows that this particular packet which has arrived containing destination address. This will have to be moved to interface 2, which is connecting network 2. This is how is happening. You got the idea. Now there is some concept called as block allocation. Now this concept is not that very important, basically. But anyway, I'm going to deal with it. So basically, block allocation is, responsibility of a global authority called as, Internet Corporation for Assigned Names and Numbers. So this ICANN, assigns a large block of what I meant to say address to Internet Service Provider. It can just you provide a bulk of addresses to ISP. You got the idea. And for proper operation, CIDR has two restrictions imposed on this. So the first restriction, what it will do is number of requested addresses, capital N. So ISP requests for a number of addresses. So this ICANN, it is supposed to give a block of addresses to a particular organization. You got the idea, and that organization has to request what I mean to say. Organization means that ISP, Internet Service Provider, will have to request to ICANN. I want this much block of address. Now here the restriction imposed by CEDAR is that number of what I mean to say addresses should be a power of 2. Should be a power of 2. This is the restriction that is imposed. So here n is equal to, since we have this formula, number of network addresses that are allocated is nothing but 2 raised to power 32 minus n. So I can calculate n. N means the prefix length. Prefix length, if you take a log to the base n, log to the base 2 of both sides, you will be getting this value. You got the idea? So this becomes log to the base 2 of n, and this will be 32 minus n here, because log 2 to 2 thus becomes 1. So I can take the number of prefix length to be 32 minus log n to the base 2, where n is the size of what I mean to say network. I mean to say number of addresses, network addresses. So this is how. Now if n is, capital N is not power of 2, what should we do? How much of block of addresses should be assigned to this, what I mean to say, ISP? Now here, what I'll be doing is, suppose the number is 1000. ISP has requested for 1000 addresses. Now this 1000 is not, cannot be expressed as power of 2. So what I'll be doing, the nearest power of 2, approximately equal to 1000, is 1024. Is 1024. You got the idea? So 1000, I could have taken it as 512 also, nearest if you say 500. But the ISP has requested for 1000. What I'm saying. Addresses, network addresses. 1000 network addresses means if I allocate 512 network addresses, it is not going to suffice, which is 2 to the power 9. But 2 to the power n, if I take that, as 10, what will happen? 2 to the power 10 is 1024, which is almost approximately equal to 1000. So I have, whenever the request comes for a number of what I mean to say network addresses, which is not what I mean to say, which is not power of 2, I'll take higher power of 2 nearest to the number. Higher power of 2 means any number that can be expressed as some power of 2 higher to the given value. Higher to the given value. So requested block needs to be allocated where there is an adequate number of contiguous addresses. So contiguous addresses should be there, right? So, and the second restriction they have imposed is first address needs to be divisible by the number of addresses in the block. Now this is very important. Through example, I'll explain this, how exactly this happens. Right, so I have first address is nothing but prefix in the decimal form into 2 raised to power 32 minus n. So prefix in decimal into n, if I take, that will be the first address, right? So if you take this, an ISP has requested for 1000 addresses to ICANN. 1000 addresses it has requested. Now 1000, I know that it is not a power of 2. So what I'll be doing is I'll search for a number which is some power of 2 higher than this number 1000 and approximately equal to 1000. Approximately equal to 1000. I cannot take 2 raised to power 9 because that will be only 512, which is not close to 1000. So I'll neglect that. 2 raised to power 10 happens to be 1024. So I take this net addresses, number of addresses that are granted to this ISP will be 1024 address. Though ISP had asked for only 1000 addresses, but it is granted power of 2, a power of 2, that is 1024 addresses. Now, I want to calculate the prefix length. I have formula. n is equal to 32 minus log of log to the base 2 and capital N. Capital N we have 1024. So this is nothing but log 2 into log to the base 2, 2 to the power 10. So I see that this value calculates to 10. 32 minus 10, I have 22 is the prefix length. You got the idea? 22 is the prefix length. So that is what I got. You got the idea? And then when that is there, so here this address now becomes whatever this is 18, 14, 12, 0. So you convert this 18 into binary number, 14 into binary number, 12 into binary, and then all zeros. This is there. So the first address will be what? First 22 bits of this entire thing, first 22 bits. So that is 8 plus 8, 16 plus 6 bits. 4 plus 2, 6 bits. So remaining 10 bits. You got the idea? Are all made 0. Are all made 0. So if I now calculate the binary, decimal equivalent of this number, it translates to this big number. So this is a big number. So roughly it is equal to 30 crores, 29 lakhs, 10,464 can be taken to be somewhere around, this big number. And if you see whatever first address that I have calculated by the restriction now, I have a restriction that this particular first address should be divisible by, you got the idea, number of addresses in the block. Now, first address need to be divisible by number of addresses in the block. Now, number of addresses in the block I have taken as 1024, 1024. Though I had asked for 1000, but I was given 1024. And you can see this big number first address is divisible by this. Can anybody solve to check whether this 302910464 is divisible by 1024? Check it fast and tell me.
Yes, sir.
Yes, sir, it is divisible.
It is divisible.
Yes, sir.
So I get 295811 as the quotient. So this is what it has to be satisfying. So this everybody has understood what I have explained.
Yes, sir.
Okay. Now we will go for the students. I have uploaded videos in 4 parts of date 7th April. Today I'll be uploading 8th April, and before that, I mean to say before that, whatever videos slowly I'll be uploading on my YouTube. If you want, you can download that and subscribe that, and probably if some friends are there, those whom you want to benefit them, you can share, and that's a simple thing. You got the idea? So now here in the hierarchy what we had seen yesterday, we can use subnetting, subnetting and all. That means of a given network I can create many subnetworks, subnetworks and all. Of course, not that so far it has not been asked in examination, but anyway I'd prefer to explain the concept. So how do I design the subnets? So basically, whenever we are designing the subnet, we have to be very careful, because based on this subnets only, subnet design, our routing of the packets will take place. So if your design of what I meant to say subnets is not proper, routing becomes difficult. So we'll make certain assumptions. Here we'll make certain assumptions. Say total number of addresses granted, I'll be taking it as capital N. From beginning we have been seeing that we have taken capital N is the total number of addresses, network addresses that are being granted by ICANN to the internet service provider, and the prefix length I'll take it as small n, You got the idea? And the assigned number of addresses to each subnetwork is cap n subnetwork. So out of total organization, what I meant to say has been allocated with what I meant to say n network addresses. Out of that, you got the idea, assigned the number of addresses to each subnetwork. So suppose total number of networks is 32. Now 32 is there. So it has been divided into four parts, four subnetworks. So first subnetwork will be given what I mean to say 8 addresses. Second subnetwork will be given 8 addresses. Third will be given 8 addresses, and fourth one will also be given 8 addresses. Now, if I have 6 subnetworks, 32 are the granted address. Granted address means I told you that network addresses should be always power of 2. So 32 is nothing but 2 to the power 5. So definitely these are the network addresses. So 32 addresses are there, but I want to create 6 subnetworks out of this. Now 6 subnetworks of this means it can be designed in any form. Suppose first network is given as 10, what I meant to say, 10 subnetwork, first subnetwork is given 10 network address. Second one is given 6, what I meant to say, network addresses. So total 16 out of 32 has become. Third subnet has been given 4, what I'm saying, network addresses. So this becomes 20. You got the idea? Fourth is given somewhere around 6 network addresses. So this becomes 26. You got the idea? So total how many? 4 network sub are there, and remaining one what I meant to say subnet has been given 4 what I meant to say addresses. So 26 plus 4, it becomes 30, and the last one is given only 2 addresses, 32. So this is how the subnetwork has been divided into 6 parts, 32. Not necessary that it should be equal in size. It can be any size. So this is what is there. Following steps carefully are to be followed to guarantee the proper operation of subnetworks. So number of addresses should be, number of addresses in each subnetwork should be power of 2. Now this is important. You should remember, prefix length of each subnetwork should be found using this particular formula. This is the formula. That first address is prefix in decimal. You got the idea? Into 2 raised to power 32 minus n. So this is nothing but this was equal to capital N. This was capital N. So prefix in decimal into capital N. This is what is first address, and n sub. N sub is calculated by formula 32 minus. You got the idea? Log 2, log to the base 2 n sub. This is the formula. So the starting address in each subnetwork should be divisible by the number of addresses in that subnetwork. Again, it's the same concept for the networking what we have seen. It is for subnetwork. It is applicable the same way. Here, only instead of what I would say small n, we had n sub, and capital N, we have capital N sub. This is what is that. So this is the